Okay, so I'm going to explain why the hell you would bother having a gearbox, pulleys, tensioners, belts, all of this complication under here. Why would we bother to do that? And there's a number of reasons, but probably the biggest one is really the dynamics of what's going on under here. So we've got these two mills that are quite heavy and they're spinning at very nearly 3,000 RPM. So there's a lot of balance and dynamics in that. And if things go wrong, they go wrong really badly. And the reason we have belts is to keep them isolated from each other. We don't want this one rigidly connected to that one. In case something bad happens to this one, it tears up the drive line between those mills and it tears up the other mill as well. So I've seen some crazy stuff happen. I've seen Makita drills, brand new, go through these things. I've seen rows of spanners. And the Seed Terminator mill is pretty robust, but there's a limit. And sometimes things go wrong. So what we want is we want it to be able to be independent. So we've got basically the gearbox going to each of those mills independently. If something bad happens here, or if this one gets loaded up, it's enabled to slip. If this one loads up or something bad happens to it, it's enabled to slip. And there's just that independence from each other. The other big thing that we work on is that because we've got the gearbox isolated from those mills, something bad happens to the mill, it does not happen to that gearbox. So the gearbox has got the ability to operate in a safe environment with minimal shock. So if you imagine if this was connected by a rigid drive shaft or a rigid connection, then we would see a shock load happen here at this milling operation, damage the gearbox, and ultimately that's your expensive component. So we keep the gearbox in what it's intended to do, to change the direction of rotation and isolate that load. The other thing that we can do is because we've got the belts, we can actually have the speed up operation happen with the belts as well. So the gearbox runs at 1500 RPM or 1580 and the mills are at around 2950 RPM. So we've got the gearbox running at about half the speed, a bit over half the speed of the mills. So what that means is that gearbox heat a lot of that's actually generated by oil splashing around in that gearbox. And if you haven't got the speed, you haven't got that oil splashing around and you haven't got heat. So that gearbox is especially designed, it's got highly efficient teeth engagement with spiral bevel gears, but it doesn't have the high speed of the mills, so it runs cool, it doesn't need a cooling system. So we don't have the complication of a cooling system, we don't have the energy losses of a cooling system, we maintain the efficiency of the driveline through isolating the speed away from that gearbox. We isolate the loads away from the gearbox to stop the gearbox from getting damaged under a high impact stress event. And basically, we add some complication with belts, but they become our slip joints. They become the safety net for things going wrong, because we all know that sometimes something stupid happens. Thanks, guys.